Good afternoon, everyone. Sorry for being late, and I just give me a second so I can upload my background. Yeah.
Okay, doesn't matter, Prof. Huang.
Hi.
Yeah, nice
Yeah.
meeting you.
Very nice to meet you too. And yeah, as I said, just give me a second. I need to see.
Okay, so I would like to welcome to all participants first, Prof. Huang.
Yes.
Yeah,
Hi, everyone. Yes.
yeah. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. And also our honorable guest lecturer, Prof. Huang X Nguyen, that already with us this afternoon. Welcome, Prof. Huang.
Hi, and good afternoon, everyone. Thank you, Diaz.
Okay, so first of all, I would like to invite Pak Lutfan first to open these guest lecture sessions. So the time is yours, Pak Lutfan.
Thank you.
Yeah, thank you very much, Bu Dia. Yeah, good afternoon, everyone. Please allow me to introduce myself. My name is Lutfan Lazwardi, and I am currently the head of the Department of Health Policy and Management at the Faculty of Medicine, Public Health, and Nursing at Gajah Mada University. And I'm very pleased to introduce you with Professor Huan Nguyen of the Middlesex University that today are able to meet with us, although online, that will inform us about the digital twin. And I think this topic is something which is new to most of us, including me also. But I'm very sure that we will learn a lot and we'll see also the potential benefit that we can actually then work later on. And just for your information also that this is part of the collaborations between Gajah Mada University and Middlesex University, and is funded by the British Council uh, uh, with the aim actually to develop the connected curriculum related to the digital twin for health system resilience. But I think we expect to have long-lasting collaborations, and I'm actually very sure that we would like to have more activity within the project also. And yeah, not to make a further ado. Thank you very much, Professor Juan Nguyen, that will give us the very important topic related to digital twin. And will Bapak Ibu semua semoga bermanfaat. And yeah, we're looking forward for your talk. Thank you. So back to Budia.
Okay, thank you, Pak Lutfan. So now I would like to invite Prof. Huan X Nguyen to present. But before that, I would like to introduce Prof. Huan first. So Prof. Huan X Nguyen, PhD, SMIEEE our guest lecture today that will share for us on the topic of digital twin for health system resilience. So Prof. Huan currently is a professor or chair of digital communication engineering and digital director of also of London Digital Twin Research Center, and also head of SG 6G and IoT Research Group, and also member of Faculty Research and Knowledge Transfer Committee, and also the coordinator of Department's Research Excellence Framework in 2021 team. And also he actively as postdoctoral supervisor at the Middlesex University, London. And He is also has a background of electrical engineering and telecommunications, graduate from University of Science and Technology in Vietnam, Hanoi, and obtained his PhD in electrical engineering, University of New South Wales, Australia. So we are proudly welcome Prof. Huan to share with us his experience and knowledge on digital twin technology. And I'm curious to know, what is digital technology especially, and how it can be applied in health sector. So the time is yours.
Thank you very much, Diad, and thank you for the kind introduction. And again, good afternoon, everyone. I apologize again for being late, but now hopefully we can get to the lecture. I just wanted today just to together we share some of what we found about the digital twin technology and open some discussion on the application of digital twin for the healthcare sector. And hopefully we get some input, some comment from you as well. And let me share the screen and hope, can the host, any of you, can you allow me to share the screen? Khalifa, anyone who is a host?
Okay. So Hanifa, could you kindly
Allow me to share the screen? Yes,
Yeah.
please. Let me see if I am the co-host line, so I can share my screen.
Yeah, we can see the screen now.
Thank you. Okay, and let me move this thing around and then. So, digital twin, the state of play and the use case of healthcare resilience. So, as Lufan said, is a part of the outgoing global partnership funded by the British Council. And this is a partnership between the UGM and the Middlesex University London. And where actually the London Digital Twin Research Center is based on. And this project is implemented as a London Digital Twin Research Center, where I am the director. So a bit of information about myself, you can see from the screen here. I am, as I said, I'm the director of that center. At the same time, I am also the head of the 5G, 6G, and IoT research group. And my research area is about digital twinning, optimization, 5G, 6G, and IoT. And basically, my focus is on digital and virtual solution, or sometimes we call smart solution for different area, including smart manufacturing, and now is healthcare, and of course, in communication as well. So, yeah, this is the website of the center, but yesterday I checked the website, there is some, it's not functioning as should be, but if we will rectify that quickly. But if you got a chance, you just go to the website dt.mdh.ac.uk, and then we have a lot more information to share with you. So the research center, I founded this research center in March 2020, but our research on digital twin has been dated back to earlier days. And this is a like interdepartmental collaboration between different departments from Middlesex University, including design engineering, mathematics, computer science, and natural sciences. And we got a number of funded projects with international partners. And yes, UGM is one of our partners. We have the partner from Turkey, India, France, Belgium, USA, and Vietnam as well. And we got a number of industrial partners. You can see from the right hand side, that is just the list, a few of them. Okay, and so I know yesterday I already introduced about Accenture to some of you at the meeting in the hospital, so I don't want to show it again, but if you see, maybe I run the video a little bit. I'm not going to run it for the whole section, but I ask you if you got a chance, go to our website, you can watch this video. But I can open it for a couple of minutes. The future is about the digital technology, about the new and advanced digital twin has been picking up pace since 2017. A lot of companies can see the potential application of the digital twin technology.
A digital twin is a computational model that is a representation of a real world entity. Instead of making changes to physical system or workforce or a company operations and cause chaos if it doesn't work, we create a replica of that system in the digital world that allows us to explore those opportunities and changes and their impact before we deploy it into the real world. The London Digital Twin Research Centre was
founded in March 2020, and before that we already been doing research
to explore digital twins in manufacturing related areas. Why would a company adopt a digital twin, and how will they justify investing into new technology?
So the center will provide them with the technology, the validation, the demonstration of the work, and to bridge the gap between academic and the industry. So we try to develop a digital twin model of the smart factory.
So in Middlesex University, we have this Festo Cyberphysical lab. It's an assembly line. What it does, it assembles a mock mobile device. You can collect all this data and analyze it, apply different machine learning solutions.
And that also can help you to optimize the processes, including how we can detect any potential damage. And also we can optimize the life cycle of the system.
We are trying to build a digital twin that can be adopted as a baseline by industries, that they can build their solutions on top of this one.
What we can help that, we can build the I think I just stop right there because we may not have time to show everything. But you can see on the right hand side that is a different application domain for the research of digital twin in our center. So like industry 4, as I said, in telecom, in heritage, restoration or structure, agriculture, and yes, in this project we focus on the healthcare. So before going into the detail of the digital twin technology, I want to give some perspective the technology trends going on around the world. So you know that a lot of you know Gartner is the company that providing the reports and the technology trends for every single year. You can see the last 3 years. You can see like in 2020, they got the digital twin is one of the top trend technologies. And you can see the other thing like autonomous things, augmented analytics, or blockchains. And so 2021, you got the Internet of Behaviors and so on. And then 2022, you can see a number of different technology trends as well. You can see. And so in my opinion, I divided in that the technology trend into 3 pillars. And the first one is that the boundary between the virtual and the real worlds is getting blurry. So you don't have very clear boundary anymore. It is just like the 2 worlds, the virtual one and the real one, are just combined together in a lot of different ways. And with that, you can see that the enabling technology for that is like VR, AR, XR, AI, digital twin, the metaverse, and so on. So with that, it comes with a lot of opportunities that also come with what we call the trends. So that the digital business, you can see the evolving or the the development of game industry or the digital currency, bitcoins and so on, and digital goods, brands, and you can see that even digital arts. Now, a lot of the artists, they don't just have to do the painting, they can do that, create the arts in the digital platform. And you may heard about the NFT, right? I will come back to that later. The non-fungible token. Distributed enterprise or generative AI, that also the enabling technology for the digital business. But you see that with a lot of people going digital these days, there are digital risks as well. So you can see that we come with like the online identity, online avatars. It need to have the data privacy and protection mechanism in place. Okay, so that's why the development of like cyber security and so on, or even that's a PEC, privacy enhancing computation and so on, even blockchain for the purpose of security. So that the technology trend to develop with the 3 pillars. And today we focus on just the digital twins only, and the one on the left-hand side. But now, look at this. I want just to give some example of the technology trend, like the generative AI. It uses a lot to create digital arts, digital goods, and so on. So you can see that all the people in these photos, none of them exist at all. None of them are real. All of them are created by the AI, right? So you can see look very real, but they are not the real people at all. Or the picture, the painting on the right-hand side actually is a portrait of Edmund Bellamy. And that's using just a gun, the generative adversarial network. And it's created by completely the AI here. And it has been sold for like more than $4,100 at the Christie's auction house. So you can see now it's getting more and more that the digital arts, the digital goods can be created here and become a good market. So the market will dictate technology as well, right? And another one I mentioned earlier, like non-fungible token. Okay, what is this? And this also the technologies that based on the blockchain one, and but similar to crypto, based on blockchain, but this one is non-fungible. What does this mean? That means you cannot exchange them. Each of the token is unique. Because it's unique, so it can represent a unique object. And typically like the digital art, painting, music, or video game items. Okay, so we know that without the NFTs, digital assets are easy to share, but difficult to own. So with the NFT now, you can own a digital goods or the digital assets. So for example, now, on the right-hand side, you can see that is a artwork, NFT artwork. It sells for $69 million at Christie auction in March 2021. And absolutely using the NFTs here, so it can be owned by this is the digital goods, the digital art, so it can be owned by digital platform NFT. Without the NFT, it's very difficult to claim that you are the owner of this. So another example that is the very first one is down on the bottom right. You can see that the very first tweet sent by Jack. So Jack Dorsey is a former CEO of Twitter and Square, right? And he proved that he used the NFT to put he is the owner of this tweet, the very first tweet in 2006. And he sold his first tweet as an NFT for over nearly $3 million. So you can see that you may say that I don't understand why somebody can buy this for $3 million, but there is a market for this digital arts or digital goods. And as I said, digital assets are easy to share, but they're very difficult to own. But thanks to NFT, now you can prove that you can have the ownership in the digital platform. I mentioned another pillar is about the privacy and security. Of course, it's very important that in this digital era, we want the data to be shared widely across the different system, ecosystem. Yet we want to preserve privacy. And but privacy in this now, because the boundary between the virtual and real world getting blurry, making privacy is difficult, okay, a challenge. So you see that service of scalability is always been demanded, but then security could not keep up with. So there are always platform for you to do research, to do more investigation, to improve the security solution. So that is a technology trend as well. So I just summarize again that, because to open the talk about digital twin, I want to give you some perspective, some of the current top, technology trends. We can just summarize that going digital or virtual now is a trend, and the digital goods or creator as a huge market. And you need to embrace the digital age or you will be left behind. However, yeah, you need to engineer trust and the data protection to make sure that your platform is secure enough for the users to use. So how about the digital twinning? And digital twinning got a lot of connection with the metaverse as well, but I don't think within the scope of the talk today, I wouldn't be able to share both of them. So maybe next time, hopefully another workshop, I can share with you about the metaverse, but today is just about the digital twinning, digital twins. So, okay, what is digital twin? I gave the two quotes from the two big guys, CTO of IBM, and the other one is SVP of Aras, Mark Lin, and Sky Matthews. And Sky Matthews just confirmed that this twin is really a hot new emerging technologies, but at the same time, it's a real thing. Okay, but then Mark Lin just give you a true picture right now that the digital twin is still very much immature. And a lot of people are going to do research development on that. But if you ask 3 people what the digital twin is, you may get 5 different answers. So like here's a different definition of digital twin. Deloitte is a consultancy firm that can also help a lot in formulate the market and so on. They also define digital twin as fundamentally as an evolving digital profile of the historical and current behavior of a physical object or process that help optimize business performance. Okay, and or IBM can have even more comprehensive definition of this. Well, sorry. I don't want to repeat this one, but just to tell you that a different company, they also have the different definition of this, but more or less it's the same message that this is the digital representation of a physical object. But there is some characteristic, not just a digital representation, but there are some characteristic that you need to take into account. And I will show that in our, excuse me, in our own definition later. But you may ask that, okay, if it's a replication of a physical object, then is that just the simulation approach that we have done for ages? In simulation, we try to replicate a real system, right? Okay, so we need to answer this question. Or someone may ask that, okay, this may be just a traditional simulation with the added AI or machine learning element to this. Okay, let's see if that's the case. And but before going to answer that question, I want to go directly into that why we need to have digital twin. And initially, digital twin has been used for to improve the productivity and to manage the product life cycle or to manage the assets, right? And then it comes with the maintenance and the health issue. because it can predict the uncertainties in advance or give early warnings. If you got the structure, very important structure, that you can give early warnings that you may need to do maintenance very soon, that's much better than waiting for the damage to happen before we take the we react to that. Okay, so that can reduce a lot of risks of the accident and so on. And you can see that the digital later on can be used for efficient operation of an organization or of the enterprise, companies, business, and even it can help to replicate, to run different business model to see which one is the optimal one. So a lot of that come with what we call the what if scenario. If you can run thousands of what if scenario, so you can actually look into the future, isn't it? The question is how accurate they are. So that always is an evolving process. If this is the twin can run 1,000 of scenario, what if scenario, that means the scenario can happen in the future. Then it's give you much better planning, isn't it? Okay, in any operation. But going back to the history of the digital twin, was the origin, as I said, that I think it's dated back to the NASA's Apollo 13 mission. A lot of you remember that it around 1970, right? And then the mission to rescue the Apollo 13, NASA had to build like the digital version, more or less a digital version of the real spaceship, and try to replicate the real condition over there and make sure that they make the right decision to rescue the spaceship back on track to go back to the Earth. So that is the idea already there back in the 1970. And then David in his book also mentioned about the mirror worms, and a lot of idea very similar to the idea of digital twin nowadays, but it's only in his book at the time. And then Michael Gribbs, he's still very famous now in the area of digital twin. In 2002, he done presentation for the virtual space in product line management, and that initiate all the concept about digital twin now. Okay, but the real term digital twin actually has been introduced by John Vickers from NASA in 2010. So on the bottom, you got the two graphs over there. You can see that the interest in digital twin in the last decade, from 2016, you can see certainly 2016-17, the interest in digital twin has been picking up exponentially. You can see the Google searches for the keyword of digital twin going up like that. And then the research article about digital twin in Scopus also increasing exponentially in the last few years. Now, I wanted to pay attention to what I mentioned earlier in the question, that digital twin is just the traditional simulation. Because I mentioned about the replication of the real system or the real object or the physical object. Exactly that the simulation we has been doing for a long time, isn't it? But there are some different. There's the key concept of digital twin. You need to pay attention to three things. That is, the two systems should normally exist side by side. So the physical one and digital one should exist side by side on the real-time basis, right? And it evolving together through the data information exchange to achieve the optimal state of operation. So here, there is always the real-time data exchange or information exchange between the digital one and the physical one. Okay. So once in simulation, once you replicate, you design the simulator, it just normally finish there. You run simulation and then you finish. You achieve what you want. We call that you achieve the destination. But in digital twin, there is no destination. It's just like a journey. you have to keep going until very much the end of the physical object. So the digital version keep evolving with time. Any change in the physical system will be reflected in the digital one. That's why we say that it should exist side by side on the real-time basis, and it need to evolving together. The second bit is that the level of intelligence it bringing in the digital twin system is a lot more. Okay, with the advances of the AI, of the machine learning technology, with the availability of the data, we can do a lot of learning. We can bring a lot of intelligence or the automation into the digital twin. So that's why the digital twin will help bring in wider intelligence to provide seamless monitoring, analysis, and evaluation, as well as the prediction of the complex system. Okay, so that is a target. Whether you can achieve that is another thing. Okay, whether you can achieve that is another thing. Now, the third one, as I said, the digital twin needs to last for the whole life cycle of the physical system. Okay, it cannot just that you design a simulation and then you stop there. No, it's not just a beginning. It needs to keep evolving. Any change in the physical system, it needs to be updated, and then the digital need to reflect accordingly and run the data again, data analytics again, and then provide a different decision back to the physical system. Well, this is all theoretical stuff, so maybe it's quite still difficult to understand. But let's make one example. If we design a digital twin of, let's say, of the heart, we call cardiac digital twin of a patient, right? I want to be able to connect that between the digital heart with the real heart. Okay, so anything changed in the real heart will be reflected and analyzed in the digital heart, and then the digital heart can provide a decision, can make a decision that, okay, you need to do certain treatment to the patient, for example. So that is an evolving process, for example. So that's one of the examples that why the digital twin is very also have a great potential in the healthcare sector. Okay. You see that on the right hand side, just show a different enabling technology and the use cases, and healthcare is certainly one of them in there. And for the enabling technology, you need to use a different machine learning algorithm via AI, distributed computing, cyber physical system IoT, or industrial IoT, and so on. Okay. Again, at our London Digital Twin Research Center, we also try to make sure that we got our own definition, because now a lot of definition around the world. So we also have a very comprehensive one, like this twin is a self-adapting, self-regulating, self-monitoring system of systems. So it's quite complicated than the normal one. So it is characterized by the two-way communication between the physical entity and the virtual representation. And remember that the digital twin can have a different fidelity or the rate of synchronization. Sometimes you want the digital twin is very accurate, which means that high fidelity, or you want just very low fidelity, just showing briefly the physical system, not with the high accuracy, because in some use cases you don't need to have very high fidelity. In that case, the rate of synchronization between the physical one and the digital one is less as well, and then it will require less computing resources. Okay, so that is mainly the definition, but I want to excuse me. I want to show you that, okay, there is certainly the digital market now, and it's picking up a lot in the last few years. Okay, in 2020, the market is 3.2 billion US dollar. And but it's going to be expected to go up to 48, nearly 50 US dollar, 50 billion US dollar by 2026, right? Okay, and with the compound annual growth rate of 58%, and normally it's around 35% already is a good growth rate, but here is almost 60%. So absolutely the market is there. And you see that if we do, represent the growth rate in terms of the graph, you can see that it increasing like exponentially. Okay, and here is more of the number, but it just so in different field like automotive, transportation, energy and utility, home and commercial. That's a market always have in oil and gas, even in healthcare. Here you can see that it's picking up. You see with the rate of 81%, it's very, very high as well. Okay, the growth rate is very, very high. The distant landscape is just to show that who is involving in the development of digital twin. Of course, you can see a number of different firms for that. I'm not going to go through all of them. But now, before going into this, I just want to ask if any of you got any question for me.
Okay. Any questions from
Any
the
questions
audience?
about the first part?
Yeah.
It's okay. We can have the question later on.
Yeah.
If you have. So now I want to move into the next section. Is about the use cases. Of course, we want to talk more about the healthcare, but I also want to show that different use cases of digital twin, and hopefully that maybe any one of you involving in those use cases or maybe have the research related to that, we can always have a good chance of collaboration. Okay, so digital twins are expanding rapidly and in different domains with different applications. So you can see here again this picture just to show you the different areas that have application digital twin, from manufacturing, asset management, logistics, energy, gas and oil, aerospace, structure, environment, telecommunication, and of course it's healthcare, right? So I just briefly go around different areas just to mention some of the headline here. You can see that now in manufacturing, for example, Rolls-Royce turned to digital twins to improve the jet engine efficiency. Example, because you know that the jet engine efficiency, jet engine for the planes, it's very important that you cannot take for granted the safety of the plane, of the jet engine. So if the digital twin can help improve efficiency, the safety, then that's always good. And some of the things you can do the trial, or you can design using in the digital platform, then that will be much better. You can optimize, you can improve the efficiency. Okay, or in aerospace is similar, right? Like by modeling for the phenomena to better predict the engine decoration over time, that it can save tens of millions of dollars for the customer. Or the digital twin in the cockpits will help planes look after themselves. I think that has been developed for some time, that the plane can do the autopilot things, but not just autopilot. In the future, the plane can even look after themselves, can do a lot of automation, and can react to different situations, because digital twin is just like the digital version. Or let's say that is the brain of the plane that react to different scenario, because in his head the digital twin can run thousands of different what if scenario that can help you to look after the plane, for example. Yeah, NASA space program. We don't have to go back to Apollo 13, but it's the reason all the recent activities for NASA. They has been always very advanced in the digital twin development. Whether they call that digital twin or something else, that is actually still the digital twin technology. One example, like, is the landing of the Perseverance rover on Mars in 2020, I think, and they use very much the digital twin of the rover for the landing, isn't it? So when it's the few moments before landing, it need to find the right place to land. So it take the photo, find out what is a good terrain to land on. So all the decisions need to be taken in real time. And that is a part of the interaction between the real the real hardware with the digital twin of the rover. So that is, you can see that is a good example. If I click on here, you can see that the moment maybe it's land on
Velocity solution 3.3 meters per second, altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface of Mars. Perseverance is continuing to descend on the parachute. Navigation.
Climbing. TBA is
so it very much that it is a different technology in the digital here. I think I mentioned here like the range trigger, the terrain relative navigation to know where it's heading to, even that to be able to divert to a safer place if it's headed towards a hazard terrain, for example. So it all of that is a part of the digital twin system here. Okay. Smart city, that's another use case of the digital twin. You see that it like Singapore is a good example of that. They are very ambitious in develop what we call the digital nation, and they usually work with Dassault system using their platform called 3D experience. Okay, and they make sure that they are designing the digital twin for the whole country. I think they claim that 94% of their government services are digital from end to end. Okay, or in Sweden or the UK itself, that also they developing this smart city for different city. Like in the UK, you got London, Birmingham, and Dublin, and in Sweden, you got Stockholm. So, and in telecommunication, of course, there is always platform. Of course, my research, I've also got the connection with Ericsson. We working together, develop digital twin for different purpose in 5G, 6G network. I'm going to just skip this more technical part, maybe not relevant. And in insurance training or in business communication marketing, there is always potential. For example, in training, the simulated model has been widely adopted for training the new employees in the complex operation context, right? When I say complex operation context, it's very difficult to put them into the real operation, like in hospital, for example, in the surgery. Sometimes very difficult to get them into practice with the surgery, with the doctor. So if we can design a simulated or the digital twin models, allows them to be trained in that digital model, that's much better. They can get used to all the procedure before they going into the real hospital to practice. Right? That's another example. Formula One, another one very advanced with the digital twin, because there is strong correlation between what Formula One and or the racing car in general with the technology. And because every single a Formula One car got a lot of sensor. You know, if you, for example, in Malaysia, they got a good circuit for Formula One, they racing in Malaysia, but all the data will be transferred on real-time basis back to the team headquarters. A lot of them is in the UK, actually. And the team in the UK will analyze the data and make the decision and then provide feedback to the team in Malaysia, for example. So that if we go on exactly the concept of digital twin in there, because they do have the digital twin of their car in their technology center. Okay, and then the other one domain, I think I cannot go around, is retail, automotive, supply chain, environments, okay, and so on. But all of that, the environment, you know, that we got the European Commission got very ambitious project we call Destination Earth. They try to sorry, to develop a new digital twin of the Earth to help tackle the climate change and protect the nature. Wow, the digital twin of the Earth would be very ambitious, but I hope that they would be successful in that. But the good thing, they focus on only the climate change and protect nature, to forecast the climate, for example. So that is very good purpose as well. Very, very good goals. Now going back to sorry, to the healthcare. Yesterday we we visited the hospital, and we already have some discussion already. So I just want to initiate again that what can be done in the healthcare. Of course, this is like an area that our project team and the team from the faculty of at UGM and my team at Middlesex. At Middlesex, we got the expertise in digital twin, but the team from UGM, they of course they got the expertise in healthcare and public health, and either in the medicine and technology as well, informatics, and all of that. So together, we're trying to explore what is the potential, what's the opportunity that we can apply this twin for the healthcare to improve the healthcare resilience, especially in the context of like the COVID-19, the pandemic just happened, right? So in here, I divided into three pillars. So digital twin in healthcare can be applied for the healthcare facility and organizations, or it can be applied to individual level, like the human body, or it can be used for modeling or the medicine and device development, like the modeling of the disease, for example, or the pandemic modeling is a good example. So you can see that there is potential application, the potential use cases in the healthcare. So for the healthcare facility and organization, there is always a good opportunity for the hospital is one of them, or the health centers another, or even bigger like the Ministry of Health is as an organization. You can optimize the resources. You can manage the risks. You can improve the efficiency of the operation. You can develop even a smart hospital. And yesterday we meet with in the hospital, and then we already touched on with the staff member over there about the error mitigation in the drugs department, medicine department, because that a lot of the operation that in the time pressure environment, sometimes the human factors still result in some error. So can we use the digital technology or the digital twin in this case to help mitigate that? I think there are a lot of processes can be optimized or can be improved with the digital twins. So that is a number of potential applications that we can work together. I think I'm quite interested in this, and hopefully that we can design something together and apply to the hospital, the academic UGM academic hospital there, and would be a good use cases of the digital twin. Okay. And now for the human body, the other one we focus on a smart hospital and organization, but at the level, individual level, like a patient, a human body, there are a lot of things that we can apply digital twin tools. For example, if you can build a digital twin of a person, or even you can build a digital twin of just an organ of that person, I mentioned about the heart earlier, or it can be a lung, liver, anything. But I know that the heart, we call cardiac digital twin, is a hot topic. And a number of institutions in Europe or from the UK as well, they're trying to invest a lot of money into the big project we call cardiac digital twin. Because you know that in the future, if the digital twin can predict the heart attack, wow, if you can predict that in advance, imagine how much an impact it can have, how many people they can save, right? So you can predict the based on any irregular pattern in the heart or beat, anything like that. It can help you to predict something going to go wrong very soon. If you can have early warning, then that can save a lot of lives. Okay, so the personalized health mechanism is always a good thing because everybody is different. If you can get the data from a patient, from a body, a certain body, or from a human body, you can always have the personalized health treatment or diagnosis. Okay, so that is always a good thing because everyone is different in this way. It's the only that the digital twin can run a different scenario and then provide optimal diagnosis or optimal treatment for this. So that's the individual level. We mentioned a lot about the other organ, every other things, but even that is just normal routine. Every single person should be able to have a digital twin to take care of themselves. You know, they can give you a simple warning now. Okay, the last 1 week you didn't do a lot of exercise. If you keep going on this way, maybe this is our remaining useful life cycle. Let's say in that way. So if you can give you a warning and gives you some recommendation, you may need to change the eating habit in this way. That's always the personalized health mechanism you can do with digital twin. I'm running out of time, right? Okay, so I'm trying to finish very soon. And as mentioned, the third pillar is for the disease, for the medicine, for the device development. And you know, the pandemic modeling is one of the good things. This is one part of the project here we're trying to work on as well, the research and modeling, because a lot of that we can learn from the pandemic if we can use historical data, and then we can validate our modeling. I think in our team from India, TCS, they already have some model of the pandemic. They apply to India, but they would love to see if they can apply to the data set from Indonesia to see if the model can change or if it's still accurate or not. Another area is we call that the drug delivery. You know that sometimes we inject the drug into our body, but a lot of you may not know that the release, we call that the efficiency of drug release in the blood is not very high. Some of them even very low, like 50% or 60%. So we want to improve the drug delivery, the drug release in the body. So that one will come with a number of different things. Like you have to design the drug particle, for example, the size of that, and you design different parameters of the drugs. So if you can have the digital twin connecting or monitoring the real penetration of drug in the body, that can always help you to optimize or improve the drug delivery. Okay, or you can test the characteristic or the use of the medical device. You can do that using the digital platform. If you can build a very accurate digital twin of that medical device, then testing is become much easier. Okay. And of course, there are many other applications in that with the device in development in the healthcare sector, the medicine as well. Okay, so I just touched on quite a few number of directions. This is ongoing work, and we may not have the final answer for everything, but we are working towards some of them, and hopefully this open for potential collaboration with you. I'm sure that in the audience here, a lot of you will have something to say as well. Got a potential application. And like yesterday, we already got some good idea about that. If we can, like even during the pandemic, we have to make some tough decision about that. What COVID patient should be given the oxygen, what should be let go. When we say the word let go, it seems very harsh. But unfortunately, during the peak time of the pandemic, not just in Indonesia, but in the UK, it become a panic state. The government don't know what to do at some certain state because the healthcare system, the capacity very much limited. You cannot treat every single patient, you see, during the peak time. So that's why they have to build some emergency hospital. But even that, it doesn't, it's not able to respond to every single patient. And in that scale, how can we optimize the resources? What should we call that the resources allocation? What is the optimal one? It's very helpful for the government if they can have the digital twin for the healthcare system that help them to optimize the resource allocation. That's one example. And also how to make the tough decision as well, where the priority of the resources should be given to whom, or to what department, or to what part of the country. So many questions like that can be answered if we can develop a digital version of the healthcare system. Okay, so just before finishing with this healthcare thing, you can see that I give you some example of the some project around the world. For example, Dassault system. They got the virtual human modeling. They got the Living Heart project. Okay, their mission is to create virtual twins for the entire human body. Okay, and then usher in the new era of the medical innovation. So they are very ambitious in that as well. You know that they got a Living Heart project, but they got a Living Brain project as well to crowdsource the virtual twin of the human heart and brain. Okay, the France-based startup Sim and Cure has developed a patient-based twin for treating aneurysms. Okay, or the clinic for cardiology in the University Hospital in Germany, or even in King's College, London, it has been working on developing a digital twin of the heart. We call it a cardiac digital twin. Or the hospital in Ireland actually created a digital twin of its radiology department to test different scenarios and to effectively allocate capacity to meet the demand. Because I don't know about the Indonesia, but in the UK, you know that the waiting time for the radiology department in the radiology department is very long. You know that if you can reduce that waiting or the turnaround times, then it would be great. And I think that the digital can also help with that. Okay, so that is some of the potential application of digital twin. I open it here, and like how this thing created, of course, a lot of them we mentioned about the data-driven approach. A lot of the clinically generated data or the real-world health data, even the health suggestive data, and so on, even the online behavior. So a lot of the different sources that can help to build a digital twin depending on a certain specific use cases. Okay, so to summarize that in the healthcare sector, I think that digital twin will be the key in delivering the highly personalized treatment and intervention, right? So for individual level. And also that the human digital twin banks could one day become critical for the highly successful clinical trial matching among the other use cases. And also that this twin can be key to modeling the pandemic and the prediction and of the certain pandemic events that could happen in the future. And going back to also resource allocation and risk management in healthcare, I think that also the key application of digital twin. So just to summarize the thing about the digital twin, I think I overrun time a little bit, but a lot of you may ask that how we can develop digital twin. Maybe in another day I can share with you how we can develop a digital twin in general. How we use the different 3D engine, 3D model animation, and so on, and what is happening around the world with some of the key provider players, like you can see from here, and like General Electric, PTC, ANSYS, Microsoft, Dassault System, IBM, and so on. Okay, and just before finishing, I also want to share with you that you may ask that, is there any standard for the digital twin? Okay, so I can update you there are working groups or the national program ongoing. For example, in the UK, the UK government have what we call a national digital twin programs that we have meetings every Tuesday at 10 a.m. to update and to sit together to work on what we call an information management framework, because very important that in the digital twin, you need to be able to share data together, and the data need to be able to use by the other one as well, so that you can develop what we call an ecosystem of connected digital twin. Because the individual digital twin, isolated one is okay, but it's not as has much impact as a connected one. Okay, so now and then that in the UK you have the digital framework task group, that's the one working with a number of companies. What about North America? Okay, so in North America, we very one consortium we call Digital Twin Consortium. So in here, you can see that there are a number of big companies. They sit together and they call them the steering members. For example, like ANSYS, Autodesk, Dell, Microsoft, and so on, General Electric. So they create what they call Digital Twin Consortium. In here, they got a number of working groups. So they divide the digital twin area into different areas like aerospace and defense, healthcare and life science, infrastructure, manufacturing, and so on. Okay. So that is the ongoing work. I know that digital twin is still a new and evolving area. So therefore, we don't have the mature standard yet, but it's happening very soon. Okay, so maybe I think I need to finish here, but if we have more time, I think I can share with you the specific project on digital twin from our research center, but that's maybe another day. So thank you very much, everyone. And then if any question, happy to answer.
Okay, thank you, Prof. Huan Nguyen, for the interesting presentations. So may I ask if there are any questions or confirmations about the presentations? Please use the chat box, or you can also using raise hand that you can directly ask Prof. Huan Nguyen on the specific question that you will raise. So before any question that posed to you, Prof. Yeah, there's one question from Bapak Saidi Yusuf.
Ya, alright. Terima kasih Bu. Langsung saja kali ya.
Ya, silahkan Pak.
Ya. First of all, thank you, Professor Huan, for delivering such an exciting topic for us. This is very new for us, and lucky me to join this conversation today. I know that it's an ongoing development or ongoing work for these digital twins, especially in healthcare. But really, I'm curious about what are the scopes of digital twins? If in my mind, when I hear about digital twins, I always thinking about like organ. It's mimicking the organ, the human body. On the other side, you said that social media posts or other digital transaction probably also can be used to develop a digital twin. So is that mean that a digital twin also covers like psychological stuffs or behavior of the human, and how this is implemented?
Thank you for
you.
the question. And let me clarify. It very much depends on the the use case, the what type digital twin you're going to develop. If simply just about an organ, then very much you can think of that. Okay, you got a sensor collected data from the organs, right, of the human body, and then you can develop a digital twin of that. But as you touch on a lot of that also with the human psychology behavior, because you know that the way that the person or the patient lives can also have impact or can be an input on the digital twin. And if that person sleep very late and the pattern of sleep is not very good, he still uses social media or uses the mobile phone a lot during this late time of the day, that can be another input in the development of digital twin. So what I mean that there is no limitation the amount of the sources of the data can be used in develop digital twin. But when I mentioned about the the social media platform, it mainly maybe for the pandemic modeling or the other application as well. Because combining different sources of the data for development of digital twin also is a challenging bit. For the organs, I think mainly that at the state, we use the sensor-based data to collect that. But if you want to go for the process digital twin or for example, the modeling of the pandemic or for the other things, then absolutely the social media data can be also useful as well. Okay, I hope that you understand that the different data inputs,
Right.
data input can be different, depends on what type of digital twin you're going to develop.
Sure. Thank you.
Okay. Yeah. Any other questions? If not, then could I ask one question too, Prof. Huan?
Please.
So, do you have any examples of the usage of this digital twin in UK that also have an implication to the overall system?
An example of digital twin in the UK.
Yeah, especially if you have in a health area.
In in the healthcare area, that is an area that is quite new and difficult. I know that I mentioned about the cardiac digital twin, and I know that a team from King's College London trying to develop that, combining with a team from France. And our team also started doing in this direction. We also work with a partner from Ireland working in this, but we focus on how we can replicate the communication environment within a heart, within the body, because sometimes we want to convey the data wirelessly to the outside of the body to collect the data. So non-invasive solution for that. But the cardiac digital twin is a quite expensive project. You need a lot of money to be able to collect the data and to be able to do the trial and so on.
Okay.
For the other application, yes, from our research center, we do develop digital twin for smart factory. And you see that in the video or in some of the slide I mentioned, I can see that the digital version of that, we successfully replicate or we create a digital twin that can track everything happening in the smart factory in real-time basis. And we're now working on that if we can provide the intelligence to the digital twin, be it like predict what would happen to the system, and it can optimize, for example, energy consumption and so on. in that system. I
Okay.
think maybe when I got a chance, I can show you that video again. But it's just yeah, just to answer the question is that yes, we do have an example already.
Okay. We have one question from Ibu Intaning Tias Sudawati. Implementations of digital twin in healthcare. How can we use the digital twin for healthcare to make diagnosis or treatment? What is the difference between the two of that for the diagnosis and treatment?
For diagnosis and treatment, I think the diagnosis is just to try to find out the things. I believe that in here you use a lot of the thing you learn from the past, and then you try to find out what is that going on in that patient, what's that body. But the treatment here, the treatment is a similar way, but it's just like the second step of the process. The diagnosis happening at the beginning, when the treatment is the thing happen follow after that. So the difference between them is just very much, it's just the process is the different, but the principle of digital twin is the same. You always learn from things happen in the past. You learn from what happened in this particular patient, and then you find out that what is the optimal treatment for that patient. So it's all about that. If you can create the accurate digital twin of that patient, then you can always learn things happen in the past, and then you can always make a diagnosis, and you can create the optimal treatment in here. So yeah, I'm not sure if my answer is clear in this way, but I think that I can see that in terms of the development digital twin, it's just the same. It's the same process is the same. You use a lot of data, historical data as well, and the current data collected from the patient, and then you make the decision. Just
Okay.
that.
Yeah, and you also mentioned about the personalized medicine. So that's also the I think the future that making accuracy for a treatment, diagnosis and treatment.
Yes, very much personalized. We have every single patient. If you can see that they actually, after running the digital twin, you can see that they are quite different ones. So you can have very much a personalized treatment for each of them. It doesn't have to be the same. At the moment, the doctor, maybe that sometimes they think that, okay, they give the treatment almost the same to every patient if they have the same type of diagnosis, for example, or the same type of disease. But actually, maybe every single patient is slightly different in a certain way. And now the digital twin can help you to be even go to that accurate level of treatment.
Okay. Yeah. So Prof Wan, I think the time
It's up,
is
yeah.
up, and interesting issues or topics that could be maybe we have an opportunity to have you again in this serial of discussions, especially with the topic of the digital twins. So on behalf of Department of Health Policy Management, we would like to thank to Professor Huan X Nguyen, and also for all the participants that already gathered in this discussion. And because of the time also, we would like to say this is not the end of the discussions. Hope that we still could have another time to have the next serial. So we don't have any conclusions, but the takeaway message is with the digital twin, it is like doing a replica with its own characteristic by taking account the accuracy that this is also could be a challenge for Indonesia to use this digital twin to have a more health resilience. So before we are leaving this platform, I hope we could meet again in another serial. And I have one quote from Eleanor Roosevelt that saying the future belongs to those who believe in the beauty of their dreams. So maybe this is a message from Huan Nguyen for us. So keep going for the future together. So thank you very much, Prof. Huan Nguyen, again, and enjoy while you are in Yogyakarta.
Thank you very much, and beautiful of you. Yeah, to conclude this talk. Thank you, everyone, and I hope that we will be able to collaborate more in the future, especially with you. I can see you are an expert in the healthcare sector, all of you, and in public health. Whereas we are slightly from different background, but that's why we need to work together in this way. Again, thank you for giving me a chance for this talk. I'll see you soon, and everyone.
Okay, see you soon. So before leaving, let's us take pictures together.
Yes, let's
So for
open the camera and then we
you,
can
yeah.
have the photo together.
Okay, for you all, you could so if you have enough or good connections, you could open your camera on. So we will take pictures together. Okay. So we'll wait. Thank you. So I will count 3, 2, 1. Once more. So give your best smile. 3, 2, 1. Thank you. All hope to see you again. Thank you all.
Thank you and goodbye, everyone.
Bye.